Hello everyone. Today we're going to learn how to manually graph functions with domain restriction. What do we mean by domain restriction? Here, these are examples of function with domain restriction. So the first function is f of x equals negative 3x plus 2. That's the function. And this part is the domain restriction. It is also known as interval. Right. And the second function, g of x is equal to negative 3 over 2x plus 1, where x is greater than or equal to negative 2. And again, this part, the black part is the function, the purple part or the red part is the domain restriction or the interval. Here are the key concepts or the mathematical principles or rules that we need to follow so that we can we can attain our aim. I'm pretty sure that most of you are familiar with the four symbols here. The less than or equal to symbol, greater than or equal to symbol. So let's take a look at the first one. Whenever you see a less than symbol on the domain restriction, we're going to use an open circle, and then we're going to keep the left side or left part of the graph. I'm going to show that to you in a while. And of course, if we have, let's say, less than or equal to, we are going to use a closed circle. And why closed circle? Because there is an equal to symbol. That is your hint. You're going to use a closed circle in your graph, and then of course you're going to keep the left part. If you notice this less than or equal to symbols, we are going to keep the left part of the graph. Why? As you can see, the direction, if this is our arrowheads, it's going to the left. So with the greater than or greater than equal to, these are going to the right, so you keep the right here. When you have the equal to symbol, you're going to use the closed circle. If you don't, you are going to use the open circle. Let's go and graph the first function. F of x is equal to negative 3x plus 2, with the domain restriction of x is less than positive 1. Now, since the function is written in slope-intercept form, it's very easy to graph the line by identifying first the y-intercept. Y-intercept, or just y-intercept, or y-inter denoted by b, which is the positive 2, the constant here. Now the slope denoted by m is that number, the coefficient of x, which is negative 3 over positive 1, because we need to make it a fraction in order to identify the slope, the rise over run. This is our rise over the denominator is our run. Now we're ready to graph it. Let's start with y-intercept, positive 2. If I'm at the origin, I'm going to go up two steps. 1, 2, that is my y-intercept. Take note, guys, every time you graph, since this is if it is your first time to graph function with domain restriction, I strongly suggest that you use open circle first, although later on you need to identify whether it's a closed or open circle. So it's better to use an open circle because, of course, you can easily close it or shade it in if it is necessary based on your restriction. So positive 2 here, that is the y-intercept, and the slope is negative 3 over 1. So I go down 3, 1, 2, 3, then to the right 1, again an open circle for now. Repeat the process, 3 down, 1 right. If I need more points on the upper part of the grid, I just simply change the sign here. So from the y-intercept 2, positive 2, I go up 3, 1, 2, 3, 1 to the left. Repeat the process, 1, 2, 3, one to the left. Now if you notice, I have a line open circles. If I imagine if we connect them, you will be able to come up with a straight line. You gotta use a pencil for now. So that is the straight line. Alright, let's put the arrow there. And then, since there is a restriction here, it says x is less than 1. So if it is less than 1, it's an open circle, and we keep the left part of the graph. But from where? From where x is positive 1. If this is the x-axis, positive 1 is right here. This is positive 1. Right? I hope you can see it. It's too small. So from here, you have the line from this demarcation. We need to keep the left part of the graph, meaning this part. And then what are you gonna do with the other piece? You got to erase that part. Let's do it. Okay. So I'm gonna connect this point. This is challenging. There you go. Put the arrowhead. Now again, you need to keep this an open circle and erase this part. Now let's do together the second model problem. It says g of x is equal to the negative 3x over 2 plus 1, or negative 3 over 2x plus 1, with the restriction or domain restriction of x is greater than or equal to negative 2. Now let's go straight to the y-intercept, which is a constant, positive 1, and the slope is negative 3 over positive 2, or you can write positive 3 over negative 2. They mean the same thing. They will give you the same direction as you move along the slope. Now, let's graph it. Let's begin with the y-intercept from the origin. I move up 1. That is my y-intercept. Again, you need to use an open circle for circles for now. So positive 1, and then I move down 3, right 2. 1, 2, 3, 1, 2. So this is my second circle. Repeat the process. This is my third. Now if I need more points up here, move up 3, to the left 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. 1, 2, 3. We don't have enough space for that point. Now, before we connect these points or these circles, let's figure out first. This is what makes this model problem different, since we saw already the first one. Now let's figure out the domain restriction. It says x is greater than or equal to negative 2. Well, where is that negative 2 on x? This is my x-axis, negative 1, negative 2. This is negative 2. That circle corresponds to the domain restriction. Now, but which direction do we keep? Do we keep the left side? I mean the right side or the left side? Since it's greater than or equal to, we're gonna use a closed circle, and then we keep the right part or the right portion. So from here, we're gonna keep this part. Therefore, we're gonna connect these points from here down. Here we go. Let me try my best. I'm gonna try my best to connect them. Again, make sure you use a ruler. So this is our g of x. All right. Now, what do we do with this circle? According to this, it should be a closed circle. One last thing. So what are you gonna do with this open circle here? Since it's not part of the graph, you just simply erase it. And also, I think I forgot to mention it in the first small problem that you need to label it. But this time, we're gonna do it. So this is g of x equals negative 3 over 2x plus 1 with the restriction of x is greater than or equal to negative 2. There you have it.